Hi, I'm Mike Baiocchi, and I'm a professor in the Department of Epidemiology at Stanford University. And we're talking about behavioral measurements, in particular in pragmatic trials. And the idea here is that we're going to be embedding randomized trials in sort of like usual or typical environments that have been existing, and we're going to study it sort of like in a live session. So maybe something like we're in a healthcare system and we're looking at training physicians to talk with patients about end-of-life care. So particularly, maybe like something that's kind of sensitive, but we've got behaviors of the doctors, we've got behaviors of the patients, and we're trying to think about like quantifying that. And I'm going to talk you through first some basics about how to think about that kind of process. Then I'm going to give you some specifics, particular issues that you might encounter when thinking about doing behavioral measurements in pragmatic trials. And then I'm going to talk you through two procedures that I've used a lot in my research dealing with pragmatic trials where we're trying to elicit stuff about behaviors. So let's start with the basics. So one of the first things you'll hear from folks when you start thinking about behavioral measures is you should use validated scales. And that means like scales that other studies have used where people have checked, like, does this map the kinds of things that we want? And it's been, in particular, it's a scale or a measurement of behaviors that have been used across a number of studies. I find, first time I started thinking about that, I was like, oh, but those don't actually measure the behavioral dynamic I want. So there's like a little bit of friction there. It's like, I would much rather create my own measurement so I can measure the thing that I want. And it sort of felt like it was a scale, but maybe it was like tilted in the wrong way. And so I was going to get sort of not the quite right measurements that I want. So I want to make sure that you folks learn the thing that I did, which is that, well, if you have the same measurement and you use it in different studies, it becomes really valuable because then you can look at the difference in that measurement across studies. And that gives you some like actual very reasonable measurement of what's different between the two studies. And this is not a flawless argument, but think about if we didn't use validated scales that we could use where everybody was building their own tool. And it's sort of like if everybody had their own language, nobody would be able to communicate, nobody would be able to sort of like share information or do comparisons across different studies. So validated scales have a couple of benefits. One is that they've been assessed by other people in other studies, but they really allow you probably want to deploy them in your studies because it will allow you to compare your study to other studies. This is not an argument against using non-validated scales or scales that you build in particular for your study, ways of measuring certain behaviors that you find really interesting, that are really useful for you because you have a particular dynamic. You are doing an intervention because you think it's going to work there, and you probably have ideas about how it's happening and that kind of stuff. So what I'm arguing here for, and I think most people would agree, is that like you should be using a mix of validated scales of behaviors that other people have done. So dive into literature, find what people are using so you can compare your study to other studies, but also build your own measurements that are useful for you that really talk about the thing in particular you are studying. If you're constructing your own behavioral metrics, this is one of the easy pitfalls to avoid once someone's pointed it out, is when you can, try to focus on actions when you're talking about behaviors and try to pull out references to mental or contextual states. And let me give you an example just so it's like a little bit easier. It's like, so if you ask someone, were you speeding? Did you go too fast on the way to work today? Something like that. That's tough because there's a reference hidden in there to a contextual state. Did you go over the speed limit or something like that? If you reframe this, the action is more like, were you driving over 65 miles per hour? And so, when you are building your own scales, when you're building your own measurements of behavior, try to, as much as possible, not make a reference to a mental state, not reference to a contextual state, or have those as like separate questions, and then try to really focus on the behavior or physical actions or something like that. You'll just have an easier time. So that was a very fast, like, basics of behavioral measures. But there are wonderful textbooks that you can refer to there. Let's talk about pragmatic trials. So you are about to, if you're going to run a pragmatic trial, run a study inside of an environment that already exists. So there's a data ecosystem that typically exists already. So if you're in a healthcare system, they are collecting data for billing, or they got a lot of electronic health records. You need to go in and spend some time talking to people who are in that system and understand what are they currently collecting. check out, like, they may give you a label for the variables, but you should check out, like, is there a bunch of missing data? You should talk to them and be like, hey, is this, I know there's a variable here and people are putting numbers into it, but like, do you believe it? Right, so really do some like groundwork, some legwork to understand how much people think, like, what variables they're collecting are reasonable and, are they useful, that kind of stuff. The other thing is when you start getting into those conversations with people inside of the system that you're studying, you should ask them, are there variables that they are missing? Maybe the ecosystem, their data ecosystem grew up around and like sort of was, not really well thought out. And now there's like 5 or 6 variables that everybody would love to be recorded, but it's just not part of their regular system. And so like talk with them. And if you think it would be useful for your study, build out maybe a system that would continue to exist in the future that would collect those variables. That could be really useful to your partners. And this is all in service of the idea that, like, in a pragmatic trial, one of the major benefits is a system already exists, so you don't have to create it from scratch. And if there are variables that are pretty close or good approximations for the ones that you're interested in, you should use them. And that can like lower your cost. The people already in this are familiar with them and how to collect them, that kind of stuff. So that is a major win, but you need to be sort of thoughtful about all the little pitfalls along the way about just like, grabbing variables. Here's another thing that like can be a little bit missed is you really want to spend time understanding if you are measuring the outcomes or measuring the variables that they really care about, because oftentimes you're running a pragmatic trial in a health system because you're going to try to get them to change a behavior. We have a new intervention. We're going to help physicians talk with patients about a very uncomfortable situation, end of life care, or something like that. And we want to know, we want them to use this in the future. If it's good, if it really helps, we want them to use it in the future. You need to measure the right things. Do they want longer conversations, shorter conversations? They want people to be like, what is it that would convince the people you are working with? If they saw these numbers change, that would be really helpful. So again, there are some measures, behavioral measures that you might grab from the literature, but you need to talk to the people locally inside of your trial, inside of your ecosystem to understand what would move them. Here's the idea, or here's one of the major issues that I want to focus on for the rest of this talk, which is in a pragmatic trial, you are embedding your study in an environment where your participants, they will continue to exist in that environment, right? Like if you're working with a hospital, people working in that hospital and people getting care from that hospital will continue to be part of that system after your study has been published. So there are going to be pressures, social pressures, group membership pressures that may push them to not give you the kinds of answers that are totally truthful that you are seeking out. And that's where I want to sort of focus for the rest of this talk. So reiterating this is we are studying really fascinating things, people, but there is a problem with people, and that is that we don't always tell the truth. And it's particularly true when we have sensitive stuff to talk about. And I'm not just talking about measurement error, where we have an observed value, there's a true value, and there's just some like random symmetric error that if you took enough observations, you could average out the error and you would get closer to the true value. We are not talking about that. We are talking about uncomfortable questions that push people to answer in a consistently distorted way. So you will have certain amounts of bias that push you away from the truth. And that can be really bad because that'll make your estimates harder to get. Additionally, if you have a really uncomfortable situation, some people just won't answer. And what's happening there is the people who are potentially very interesting are just not giving you answers at all, and so they drop out of your study entirely. So you don't want to just like avoid these questions, because the sensitive questions really can be fascinating. We want to know about stigmatized medical conditions or drug use or unpopular belief. Maybe we want to, like, we're really worried about people's history with delivering care, in particular, like how they messed up. But people don't necessarily, if their answers got out, they may feel shame, they may lose their job. You have to, if you want really tough questions or really deal with thorny issues, you're going to have to get truthful answers from people. And it's particularly scary because they'll continue to be in this situation. They will continue to be part of the system where you are running this randomized trial. So they have to think about their own reputation if some of their answers crept out or something like that, or their group reputation, that kind of stuff. So again, I just want to make this really clear, is we are talking about a form of measurement error, But in particular, I'm worried about bias creeping in because people have an incentive to move their answer away from the truth in a certain direction. That's what I'm kind of worried about. That's what I want to talk with you about today. So what can we do about this? So one way that people should be doing this is offering anonymity. So you know, we as researchers tell the people we're working with, we will not be sharing your answers. And I think like that does help. That is a necessary step, but like everybody knows that there's always going to be some risk. So we have to go further than that. We can't just tell them that we want to do this, keep them anonymous, but we have to like offer other things. Another way to do this is to reduce the language. So this is why like some of these standardized scales can be really useful, because people have worked out language that is less shame-inducing or is less biasing, because it makes people feel sort of uncomfortable in answering. You can also ask related questions. So maybe like you may not ask the loaded question, but you can ask a question that has implications for whether people have actually behaved. Um, another one is like if you're using a multiple choice, is to have the answer, the really stigmatized answer available, but then you have an answer that's like kind of close but not as serious, right? Like so it's right next. So then like if people like feel okay, well at least I'm not the bad one or something like that. But you understand that by they as a researcher that they answer something fairly approximate, fairly close to it. So maybe I can sort of round them into the other category. So that's something people have done. For the rest of the talk, I'm going to tell you about another approach, which is really interesting. It's called randomized response, and here's a citation for it. It's really nice. There's some math in this paper, but there's also some really nice history and other good references there. And this is you actually tell people what to answer. This is a little bit like surprising. So let's think about like so how might a randomized response, which I haven't really described yet, why are people like answering in a biased way? And why would something like a randomized response, which again, I haven't described, like help people? So often people don't answer a stigmatizing question because they're afraid the truthful answer, even though you've promised anonymity, like the truth will get out and then their response will get known. And so we want to mitigate this pressure to be untruthful, but how do we do that? So one way is to have participants in your study who are asked to answer a sensitive yes or no question. You can do it with non-yes or no questions. It's just going to be easier because I want to explain this sort of rapidly today to do yes or no. So people are randomly assigned to one of three groups, A, B, or C. If they're assigned to A, then they will answer yes. Doesn't matter what the question is, doesn't matter what the truth is, they will answer yes. Group B, doesn't matter what, doesn't matter what the truth is, doesn't matter what the question, they will answer no. And only if they are assigned randomly to group C will they tell the truth. This is the general gist of a randomized response. So you ask a tough question, then you randomize people into one of these three groups, and they will answer accordingly. That's what I'm going to sort of explain for the rest of the time. So this is interesting. Like we're it's very weird because like we're telling people what to answer sometimes, like, and it's not really the truth. Why is this helpful at all? Well, it's because you have to like know how humans work, not so much data, but like what's happening here is we're offering people plausible deniability. We are giving them the ability to, like, if anonymity was broken, if their like survey was somehow like leaked to the press and someone saw a yes, and yes was the really naughty answer or something like that, it was the answer that nobody wanted to be associated with, they would have plausible deniability. They would be able to say, hey, I said yes because I was randomized to the group that said yes. That's what we're leveraging here. It's like humans are going to corrupt their answers to move away, in this example, away from yes because it's really stigmatized. But now we give them a good defense, which is that there was a randomized yes, and so nobody would ever know what actually happened for them. So doesn't this make this harder? Like adding in this like chance modifier? Yes, it totally does, because usually we think of the observed answer in our data set as being the true answer, but now we're adding in this chance modifier. So if I was randomized to group A, then it would modify the true answer, so we would only see yes. If I got into group B, then this chance modifier would take whatever my true answer is and convert it to a no. So that's annoying, right? Like that makes things harder. But it actually also makes things better, which is that what's going on here is we do have a bias term. And by introducing this plausible deniability, we get to reduce this bias. And the problem with bias is, like, again, we can't average over. It's not a stochastic. It's a set value. It's not going to move that much unless we change our design. I'm going to show you a picture towards the end of this slide that hopefully, or this deck that'll hopefully make this really clear. So the key is the researcher controls the chance modifier. We will be modifying this, and I'll show you some stuff in just a second. So we know what's happening on average. So we'll use some statistical properties to pull out the noise and get left with just a signal. I use this a lot in my own research. I work on violence prevention, and we've been running some programs in the slums of Nairobi, Kenya, with boys and girls in middle school and high school. And we're asking very sensitive questions, and we're trying to deal with very thorny issues, very complicated social situations. And we've tried several times to, in several different ways, to understand what's really truthfully going on. And we've had some real success in developing an intervention, working with an intervention where it seems like things are really improving rates of violence, or decreasing rates of violence, I should be clear. So we took the version of what we've been doing in Kenya. We actually ported a version of it here to Stanford, and we've been running some trials here to understand how to get good measurements. And we ran a version of this study not too long ago. I've rounded the numbers and made it like sort of easy for me to talk about during this slide. During these slides, but I'm very clearly borrowing from this wonderful paper from 1977 where they did this randomized response stuff. So if you want to get more detail on what I'm talking about, it's not about what we've done at Stanford, but you can sort of see where we were coming from. So we've got two groups that we're going to take 200 students at Stanford and randomize them into either group one, where they are asked to answer, they're randomly assigned to this, and 100 of them are asked to answer truthfully a very challenging, socially stigmatized kind of question, or the other group, which is going to do the randomized response. The group two is more interesting. So what we have is like something like one of these bingo ball roller things, and there are these little pellets. And these pellets, there are 16 pellets in this example. 10 of them are red, 3 of them just say yes, and 3 of them say no. And so before, the 100 students were asked to answer the question, they read something like this. Before reading the question, turn the globe and draw a pellet. If you draw a red pellet, answer truthfully. If you get a yes pellet, say yes. If you get a no pellet, say no. We then, just to make sure that they definitely got what was going on, the person who was like helping them orient to the question, this like randomized response procedure, had them go through a couple of versions of different, not versions, they had different kinds of questions, and just practice doing this. And then they had this little like outro just to make sure that people get what's going on here, where the person says, if I did not see you which pellet you pulled out, then I wouldn't know how to interpret your response. I wouldn't know if you answered truthfully or if you were asked to say yes or no or something like that. So basically, we're helping them understand that they can blend into the crowd. They can say that, like, I had a randomized response, all that kind of stuff. So here's the math of it, is like, if you look at so how do we get to the true answer? So we have an observed percentage, and that's where we actually get to see. But what we want is the true, actual, real people who said yes to our question. But what's interesting is we know these other quantities. We know that, like, the observed percentage, we can back out the percentage of people who say yes because we told them to say yes. And then we know what percentage of people should be answering truthfully, so we can reverse engineer what the percentage of true yeses are. So let's put some numbers to it. So we have 36 people. Once we run our study, we have 36 people who say yes. And so that means that there were observed 36 yeses out of the 100 that we randomized to this group. We know that we have 3 pellets that were randomly, 3 out of the 16 that were saying that they should always say yes. So that's the probability that someone was told to say yes. So we're backing out that frequency. And then we know that 10 out of 16 should be saying yes, because that's how many of them were told to answer truthfully. That's the 10 pellets that say answer truthfully. And we get, like, though we saw 36% saying yes, we know it's something more like 27.6. That's an estimated value. We've had some noise, the chance modifier added in there. So what's nice about this is we understand now what was happening on average, but we can't point to anybody in particular and say this person had a real yes or a real no. And just to give you a little bit of comparison, this is not we haven't published this yet, but like there is a departure between the people who were asked to answer truthfully. Fewer of them were saying yes. More of them were implicitly saying yes when they were asked to answer truthfully, which is kind of neat. So what I want to do is just draw a couple pictures and show you how I think about it. Is there are true yes, true no's and true yeses, but we see a bunch of no's, we see a bunch of yeses. These were the ones that were randomly assigned. These are the true ones. The cards say no, and we can't really distinguish those two, right? What's kind of neat about that is we can shift how many, we are in charge because we are the designers of the study, how many random no's and random yeses are available. And that shrinks the number of true ones. But what it's doing is, as you add more random no's and random yeses, you're getting higher amounts of anonymity. And that's probably reducing bias. And you could like put it all the way to the other extreme where you basically have no random yeses and no random no's, and you have everybody answer true. This kind of reduces that would reduce the amount of plausible deniability, and that might like give us a more efficient estimator because we have more what we think are true yeses and no's, but we probably have more bias as well. So more randomized responses means more variability of the estimate, but it also probably means higher amounts of anonymity, which means lower bias. So this is really the first time in my research where it became really apparent that there is a very clear bias variance trade-off going on here, which is kind of a neat thing to say. Another benefit is in group 2, the randomized response, we only had 7 people refuse to answer, and in group 1, we had more like 15, so doubling up. So providing protection by carefully crafting both your questions and the way you, the questions themselves and how you ask them can really have benefits. I don't have enough time to really talk through this, but there is another really nice technique called comparative lists, if you're interested in this. And what you do is you come up with 2 different lists, and you add in a very sensitive like topic, and randomize people to answer sort of questions about these 2 lists, and you can reverse engineer what the true population level is. So I don't have enough time because we need to keep this like short, but I wanted to make sure you were aware of it because it's another really nice technique for dealing with uncomfortable questions. So some takeaways. Because your study is pragmatic, you'll likely be embedded in a setting that already exists and will continue to exist, so you have to be really sensitive to the people around you. Leverage the systems that exist, but you also have to explore them and make sure that they are strong where they are strong, and you have to understand where they are weak. Behavioral questions can provoke people into responding untruthfully. This is particularly challenging when people are going to be stuck or like continuing to be in that system into the future, and that'll lead to biases. By thinking carefully about how you ask questions, both in the wording but also in the delivery, you can head off real challenging problems. There's a whole literature on behavioral measurements, and I hope you've gotten excited a little bit about them to sort of follow up on that. Ultimately, spend a lot of time caring about the people you're studying, listening to them, and they will lead you to some better designs. If you have any questions, feel free to email me. I would love to talk more about these ideas. All my very best to you folks.